Hello, my name is Steve Naylor, and I'm a scientist based in HSE's Science Division and a project lead on the Lloyd's Register Foundation Discovering Safety Programme. My aim with this presentation today is to provide an overview of one of the core projects being delivered as part of Phase 2 on Discovering Safety. The project's looking to promote the more proactive use of health and safety on construction projects through the use of leading indicators of health and safety performance as part of routine operations. A key aspect of this is ensuring that the right sort of health and safety data is collected routinely as part of projects to allow this. This presentation will explore some of the ways in which we're looking to achieve this as part of this particular project on the programme. The presentation is divided into four main parts. The first will provide a high-level background to the project and some of the key industry drivers behind the work. Next, I'll outline the key work stages and a timeline for delivery of the project. This will be followed by a deeper dive into three of the work stages that make up the project and progress on them to date. I'll then close by considering some of the aspirations after project completion and potential next steps. So work on discovering safety started with an initial scoping exercise across key stakeholders. The main aim of this exercise was to define key challenges facing the construction industry from a health and safety perspective and explore how better use of the routine data sets could help these challenges. These challenges then form the basis of the core projects currently being undertaken on the programme. So some of the common aspirations communicated by stakeholders as part of this scope and work are detailed on this slide here. There was a desire to be more proactive in how health and safety is practiced on projects, to move away from a reliance on lagging indicators of health and safety when measuring performance, such as lost time injury frequency rates. There was a desire to be better able to benchmark performance against peers and to learn from other projects as part of that process. To be able to better exploit the wealth of routine data generated by projects to support health and safety decision making. And there was a desire to start making the use of cutting edge data techniques, for example, to use historic project data to predict risks and performance on current projects. The main premise behind the project is that routine health and safety data collected on construction projects tends to be used mainly descriptively. So, for example, the typical scenario is a set of high-level performance indicators are agreed at the outset of a project. They're tracked and reported on retrospectively on a periodic basis over the course of the project through the use of, for example, scorecards or dashboards. Common indicators used in this context are illustrated on this slide here and include things like lagging indicators such as lost time injury rates, RIDDO reportable rates, or sickness absence rates. Perhaps indicators linked to compliance to management system arrangements, such as near miss reporting or the findings of inspections or the findings of audits. Or there may be indicators linked to the management arrangements themselves, such as the actual carrying out of audits, inspections, monitoring, or other checks, or other aspects of health and safety management systems operated. So what does being more proactive and more data-driven look like at a practical level? Having at your fingertips measures of health and safety performance, near or real time perhaps. Having end-to-end processes that start with the raw data being generated by a project and end with it being auto-collated and reported on. And perhaps having measures more directly linked to agreed actions. For example, documented risk hotspots are identified from data, perhaps triggering targeted inspections, for example. All this could potentially be taken a step further. For example, we might use techniques that analyze routine data and actually predict the likelihood of future incidents occurring using machine learning algorithms. Obviously, to be able to do this, we need to be collecting data around known precursors of accidents in a consistent and standardized way, and to be able to feed them into the analytic process easily. This raises a number of questions. What is such data? Are projects perhaps collecting it already? And if they're not, how does a project start collecting it and then start making effective use of it? These questions provide the focus of the current project. So on to an overview of the key stages of the project and a timeline for their delivery. This is illustrated on this slide here. Phase one work on the project started back in 2019 and was undertaken in partnership with a research team from the University of Manchester. This work took the form of a series of industry workshops with inputs from professionals from across the construction industry. The main output of this work was agreement on a set of 17 key leading indicators, indicators which were regarded to be particularly relevant for measuring the health and safety performance on construction projects in a holistic, collective way. Phase two work started in mid 2020 and is being carried out in partnership with the commercial organisation Wood. The first part of phase two work was recently completed and involved a series of workshops with a number of construction contractors operating across the sector in the UK and in Ireland. The aim of the workshops was to look to document the range of current data practices typically employed by contractors on their projects. These workshops had inputs from representatives from HS2, from BAM Nuttall, Multiplex, John Sisk, Blue 3, BCM, and Wood themselves. As part of this, a number of the contractors shared samples of routine health and safety data generated on their projects, such as incident reports, the findings of inspections and audit reports, and project observations data. This data, along with the data held by HSE, is being used by the HSE and Wood project team as the basis for developing new analytic tools and techniques that industry can use on their own data going forward. Going forward, stage three work on the project, planned for delivery later in the year, will look to integrate the tools and techniques developed into software solutions that perhaps can be integrated into existing proprietary software used by projects. To ensure that such work is suitably targeted, an assessment of the current software solutions market is planned, where any gaps in capability and functionality can be identified. Solutions will then be developed to specifically address these gaps. I'd now like to take a deeper dive into the various parts of the project, starting with the leading indicators of health and safety framework developed in phase one. This framework provides the foundation for phase two work and is a framework for using leading indicators of health and safety performance, specifically on construction projects. The framework identifies 17 key dimensions of performance, covering both the design and build stages of a project, and identifies all the key areas of a project that play a role in determining how well risks are controlled over the project lifecycle. As part of the work in developing the framework, industry professionals were asked to rank the 17 areas of performance in order of importance from their perspective and consider ways in which quantitative measures might be assigned to them using routine project data. So, for example, taking the top ranked indicator on the slide, organizational commitment to health and safety, this indicator is split into 3 sub-indicators in the framework, and an example of how each sub-indicator can be measured is then offered. So, for example, in the case of the sub-indicator senior management engagement, the frequency of senior management representation on site safety inspections over the duration of the project is perhaps a potential measure that could be used. All of the 16 indicators are then treated in a similar way. The work undertaken by the University of Manchester in phase one in developing the framework is the subject of a peer-reviewed paper in Safety Science recently published. Details on the paper are provided in this slide. Phase two work commenced with a series of contractors' workshops at the beginning of 2021. The aim of these workshops was to establish a detailed picture of the different ways in which routine health and safety data was collected on projects and used to form health and safety management arrangements. Key topics were things like the way different data sets are collected, how they're stored, different software solutions used to analyze data, different KPIs tracked, for example, and linkage with other data sets. All these topic areas were considered by way of a series of facilitated workshops and a online questionnaire that was administered. A number of useful insights were identified from the workshop discussions to inform later stages of the work. First off, it was evident that organizations tended to face significant challenges owing to useful data sets often being held disparately across an organization, often in different corporate IT systems. Secondly, workshop discussions confirmed anecdotal evidence that typical ways of documenting and measuring health and safety performance within organizations involve project data being brought together, typically retrospectively, for example, on a month by month basis for reporting on, and that this posed significant administrative burdens for organizations. Thirdly, all organizations had recently undertaken some data related improvement initiatives that participated in the workshop or had them currently underway or planned. For example, one contractor had recently brought all their core health and safety data sets together into a central repository with a view to improving how they could use it analytically. Another had created a data warehouse of health and safety information linked to online dashboards in order to create the capacity to report metrics automatically. Fourthly, another key finding was that the participators felt that they had insufficient data science and analytic capacity within their health and safety functions currently, such that the desire to create workflows, perhaps to automate repeat data processing tasks, or to move their data storage and analytic functions into the cloud was a real challenge for them. And fifthly, no organization had a single software solution that served all their data storage, analysis, and reporting requirements. As a result, the desire to connect their raw data sets to the software tools they used often posed significant challenges. Current work on phase two of the projects looking to leverage the knowledge value in the various data sets available to the project, including the data made available by the HSE, as well as the data shared by industry. The focus for the HSE data work is the leading indicators framework that was developed in phase one. The 17 indicators are being mapped against different regulatory requirements, standards, guidance, and good practice relevant to construction industry projects. Specific regulatory breaches observed by HSE inspectors and the context in which they occur are then being profiled in the HSE datasets being analysed. Text mining tools developed as part of other projects on discovering safety are being used to support this work. The aim ultimately is to develop tools that are able to look for similar evidence in industry datasets. The data science team in Wood is considering how current practices for dashboarding routine datasets might be enhanced through the use of novel data mining tools. For example, can clusters of incidents suggestive of new and emerging risks be identified? Or can risk hotspots on certain projects be auto-identified? Or can we flag and quantify the number of occurrences of recognized precursors of accidents around the corner, occurring in pre-text datasets, and use this as a lead indicator? Work carried out by Wood is also considering whether we can take such analyses a step further. For example, can we use machine learning techniques to identify associations between the key predictors of accidents and the occurrence of accidents in historic datasets, and then use such learning to predict the likelihood of future accidents occurring based on how current projects are being delivered? In this way, we might be able to assign a risk score to a particular project at a particular point in time using routine project data, which then might be used to target specific courses of health and safety action. For example, when a project should be inspected. As part of phase two work, current work ongoing is looking to document the current use of proprietary environment, health and safety software solutions used across the construction sector, and the specific functionality that the most commonly used solutions possess. The sorts of built-in functionality we're looking to document include the ability to build dynamic dashboards that can track KPIs real time, for example, software that have built-in text mining functionality, perhaps software that allow a user to undertake robotic process automation or personal data redaction, or tools that enable risk scores or predictive analytics to be undertaken on datasets. In the widespread absence of these sorts of tools, the aim ultimately with later stages of the project will be to target R&D work to these capability gaps with a view to building solutions to address them. The plan ultimately will be to make such tools available for industry use on their own future projects. The potential to create software agnostic tools that can be readily plugged into existing solutions will be a particular focus for the work. Going forward, the project will be interested in working with specific projects to document how any tools are being used. The construction industry, like many sectors, is starting to recognize the potential of better leveraging the knowledge value of the routine data that are generated by projects, including the health and safety data sets, to support its health and safety practices. However, inevitably, it takes time to build up a critical mass of skills and capabilities in-house to fully exploit the potential and turn aspirations into tangible tools to be deployed on projects. Discovering Safety as a research program sees itself effectively as a vehicle for addressing this capability gap. It's looking to grease the wheels for these sorts of techniques to be used more commonly on projects and to support organizations who are looking to make use of them. The Leading Indicators project is looking to take the early steps needed to make all of this happen. For those interested in further information on the project and how it's progressing, you can follow on the usual social media channels and visit the program website. These are detailed on this slide. Thank you very much for listening.